In this video, we're going to solve quadratic word problems by using completing the square. So let's look at this first word problem together. It says the height y in feet of a baseball t seconds after it is hit can be modeled by the equation below. Find the maximum height of the baseball, and how long does the baseball take to hit the ground again? So what we have here is we have a quadratic situation, and I'm just going to draw a little sketch here. And we know that the ball gets hit from some height, and it goes up, and it reaches a high point, and it comes down. And what we're trying to do here is we're trying to find essentially two values. We're trying to find the highest point, and we're trying to find when we come down here and we hit 0, we hit the ground again. And while this looks a little complicated, we know what these points are. We know that this point here is the vertex, and we know that this point here is the x-intercept. So if we can figure out a way to find those key values, we can find the maximum height of the ball, and we can find when the ball hits the ground again. Now, what you're probably thinking is it would be really nice if this whole equation was just written in vertex form. Because if we can just write this into vertex form, we could find the vertex, and that would help us to find that maximum height. So that's what we're going to do. We're going to use what we know about completing the square, and we're actually going to rewrite this into vertex form. So we're going to rewrite this equation over here. We have y equals negative 16t squared plus 96t plus 3. And we're going to rewrite this using completing the square. Now what we're going to focus on here is we're going to focus just on this part that contains the t. We're going to leave the 3 in the equation, but you do not need to worry about it right now. So we're going to focus on writing that part underlined in blue using the completing the square strategy. So the first thing we need to do is we need to create an a value that is 1. So what we're going to do is, just like before, we're going to factor out our a value. So if we factor out our a value here, we end up with negative 16, and then negative 16 divided by negative 16 is t squared, plus you have 96 divided by negative 16, which is a negative 6t. And then outside you still have this 3. So our goal is going to be to essentially complete that square that we see right there. Our goal is going to be to rewrite this so we have negative 16 something with t plus or minus a number squared, and then we'll have that plus 3 on the outside, and then we'll still have our y value over here. And we're going to add some value as we complete that square. So if we get started here, we have to figure out what this number is in here. And that's where we use our patterns of the whole a value, b value, and c value for a perfect square trinomial. So we have a is going to be equal to 1, b is going to equal whatever my number is times 2, and c is going to equal whatever my number is squared. Now if I look here at my b value, I can see my b value is a negative 6. So if I want to figure out what times 2 gives me negative 6, I take negative 6 and I divide it by 2. So here, negative 6 divided by 2 is a negative 3. So my number is negative 3. So then I can think, well, what's happening here is I have t squared, and then I have that minus 6t, and I'm adding in some number here, and I've still got that 3 on the outside. Now the number I'm adding in there is my number squared. Well, that's negative 3 squared, and I know negative 3 squared is 9. So I'm adding 9 inside of that parenthesis so that I can ultimately write t minus 3 quantity squared down here. So I have that perfect square trinomial that I can turn into t minus 3 in parentheses squared. Now if I add 9 into this parentheses over here, I have to remember that I'm also adding 9 times this a value here, which is negative 16. So I'm adding 9 times negative 16 onto the right, which means I have to add that same value onto the left. So let's just take a moment to rewrite this here. So we have y plus, 9 times negative 16 is negative 144, is equal to negative 16 t minus 3 in parentheses squared plus 3. So now I'm just going to get the y value alone, so it's in vertex form. So I add 144 to each side. I'm just going to combine it with the 3 because I can't add it inside the parentheses or anything with that squared on the outside. So my equation written in vertex form is y equals negative 16 t minus 3 quantity squared plus 147. So this is my equation written in vertex form. Now, what you should remember about vertex form is vertex form allows us to find the vertex of our quadratic equation. So if we look here, remember my vertex is the opposite of h, comma k. So that means my vertex here is a positive 3, comma 147. So I've found this value here. It's 3, comma 147. So what that's telling me is that the highest point, the highest height that my ball reaches is going to be 147 feet. So just by finding that vertex form, I was able to locate the highest point that my baseball hits. Now from here, we're going to expand this a little bit further, and we're going to look and see if we can find how long the ball takes to hit the ground, which is right here. And remember, that's your x-intercept point, and at your x-intercept points, y is equal to 0. So what we're going to do here is we're going to take our new equation and we're going to set that equal to 0 and solve. So we have 0 is equal to negative 16 t minus 3 squared plus 147. Now we're going to start by getting everything that doesn't have the t on the other side. So we're going to subtract 147 from each side. So I have negative 147 is equal to a negative 16 t minus 3 squared. Divide by negative 16, and we get 9.1875 is equal to t minus 3 squared. So then from here, we're going to square root both sides to get the squared out of there. And I end up with plus or minus the square root of 9.1875 is equal to t minus 3. So I have that equation. I can now add 3 to each side, and I get t equals 3 plus or minus the square root of 9.1875. Now, typically what we do is we would leave our answer as a simplified square root. But in a word problem, we want a little bit more information here. We want to know what that value actually means. So I'm going to give myself a little more space here so I can actually interpret that answer. And what I'm going to do is I'm actually going to square root that value so I can figure out exactly what it is. And then I'm going to estimate exactly how long my baseball is in the air. So if I take the square root of 9.1875, I find that that square root of 9.1875 is approximately, if I round to 2 decimal places, 3.03. So here I'm going to take this value here, and I have 3 is my time, 3 plus or minus essentially 3.03. So if I look at each situation, the first situation is the plus, the second situation is the minus. So I have 3 plus 3.03, which tells me it's about 6.03 seconds that ball is in the air. And then I have 3 minus 3.03, which tells me that my ball is in the air for a negative 0.03 seconds. So I have these two possibilities, and if you logically think about the problem, this negative possibility really doesn't make sense. So by using my completing the square strategy and rewriting this equation, I'm able to find that my highest point is at 147 feet and that my baseball was in the air for 6.03 seconds. So for example 2 here, it says, given the area of the shape, find the value for x. So ultimately, we're going to find the value for x that gives us the provided area, which in this case is 48 feet squared. So if I look at this example here, I'm going to set up my equation. And I know that my area of a parallelogram like this is the base times the height. So if we look here, we can see that our height is equal to x, and our base value is equal to x plus 6. So if I start to fill in these values here, my area, which is 48 feet, is equal to my base, which I'm going to put in parentheses here, which is x plus 6, and my height, which is x. So I've written out my equation here, and now my goal is to solve this. Now, written as is, this isn't very helpful, so I'm always going to start by rewriting this to get those parentheses out of there so I can start to work with this particular equation. So if I distribute here, I end up with x squared plus 6x, and then I still have that 48 on the left-hand side. So I have a couple of options here. I could, if I wanted to, I could subtract the 48 over and look at it as 0 equals x squared plus 6x minus 48 and try to figure out how to factor that. But just from looking over this, I can see that this one is kind of tricky. And so I'm going to try to use a different strategy. And so for this one, I'm going to try to use the completing the square strategy, which means I'm going to go back a step and I'm going to eliminate that right there. I'm not going to try to use factoring here. I'm just going to stick with the completing the square strategy. So here I can see that I have all of my x's on one side and my number on the other. I can also see that I have an a value equal to 1, so I don't have to do any sort of undistribution or factoring out here, which is really nice. I just need to figure out what I would need to add to the right-hand side in order to make that a perfect square trinomial so I can complete the square. So if I start to think about this, I notice that my a value is equal to 1 and my b value is equal to 6. Now I know in a perfect square trinomial, when a is 1, b is equal to 2 times my number, and c is equal to my number squared. So if b is equal to 2 times my number and b is equal to 6, my number is equal to 3. So since I know my number is equal to 3, I know that this part down here is going to become x plus 3 in parentheses squared. So now I need to figure out what I added in to create that, and I can see that my number is 3, and 3 squared is 9, so I need to add 9 in here to complete that square. And if I add 9 to the right, I also have to add 9 to the left. So 48 plus 9 is equal to 57. So here I now have my new equation. So now from here, all I need to do is solve this in order to find x. So I start by square rooting each side, and in doing so, I end up with plus or minus the square root of 57, because I square rooted a squared on the other side, is equal to x plus 3. So I'm going to subtract 3 from each side, so I have x is equal to minus 3 plus or minus the square root of 57, which to me is kind of confusing to look at. So since this is a real world problem and I actually want an estimated value for x so I know what x actually kind of is, we're actually going to square root that 57. So if I take the square root of 57 in my calculator, I find that this is approximately negative 3 plus or minus approximately, if I round to 2 decimal places, 7.55. So what I'm going to do here is I'm going to then split this up into the positive and negative version. And one option is that we'd have x equal to negative 3 plus 7.55, which would make x equal to approximately 4.55 feet. The second option is we have x equals negative 3 minus 7.55, which would give us approximately negative 10.55 feet. Now, if we think about this realistically, since we have that shape, we can't have a negative length. So here in this particular problem, we would have an x value of 4.5. So that would mean our height here is equal to 4.55. And then our base is equal to that x value of 4.55 plus 6, which is going to be about 10.55 feet.